So now we will be able to, yes. So I will share the link on Canvas later on. So even if you want the link now, I can share it with you here in the chat, Control V. So if you want to go to the link for YouTube, just and I will share it in Canvas as well. So we are sure that we have recording. I will create something in Canvas. I will call it recordings. Recordings. So each time we will update it. So today is 8. So now it's published. Each time I will update it when we have a new link. So now we will go back to our example. Can you see my screen? So now we need to solve this problem. We need to find the transfer function. So we need to find two equations. Now we have two equations. We just need to order it and make it more beautiful. So how can we do this? We need to arrange it. So just to try to make it more beautiful. So this is equation number 1. We will take equation number 1 and we will order it. So we have here I1, we have here another I1. So we will put it like this one, R1 plus LS multiplied by I1 of S, right? Minus LS multiplied by I2 of S equal V of S. So this is the first equation. Is it okay? Do you understand this equation? So I will call it 1 dash. So this is equation number 1. One more time. I just try to arrange it. So I will go to equation 2. We have here I1 multiplied by LS, negative I1 multiplied by LS. So I will write it here, minus LS, negative LS, multiplied by I1 of S. Just in the order, the same order. And after that, we have R2 plus something multiplied by I2 of S. I will write it like this one, plus R2 plus 1 divided by CS plus LS multiplied by I2 of S equals 0. So now we have the second equation, right? So now we have two equations. So the first equation is something multiplied by I1 minus LS multiplied by I2 equal VS. The second equation is minus LS multiplied by I1 minus plus something multiplied by I2 equals 0. So now I can write it in matrix 4, in matrix notation. So because this is something multiplied by I1 and I2, so I can put it in equation like this one, a matrix notation like this one. This one will be R1 plus LS, the coefficient of I1, and here we will put the coefficient of I1 also in the second row, so it will be minus LS. And in the second column, we will write the coefficient of I2, so it will be minus LS, right? And in that part, we will write this coefficient, which is R2 plus 1 divided by CS plus LS. So now we have the coefficient in one matrix. The next one will be vector, consists of I1 and I2 equal the other part, I mean the right-hand side. The right-hand side, we have VS and we have 0. So now we have something like matrix multiplication. We have one matrix multiplied by a vector equal one vector. Remember, what is required here is to get I2 divided by V of S. So now we need to get I2. How can we get I2? So there is something called the Cramer's rule. This Cramer's rule, in fact, it's a way for solving this equation. We can solve it, in fact, in a long way, but there is one easy way for doing it. If you want to get I2, so it will equal, this is the column of I2, in fact. I mean, if we need to multiply this matrix with this vector, it will be that part multiplied by I1 minus LS multiplied by I2. that part multiplied by I1 and this part multiplied by I2. If you want to solve it for I2, just write this matrix one more time and replace this column with the output, with the right-hand side. So it will be R1 plus LS. This one will be minus LS. Here we just replace this column with the right-hand side, which is V of S and 0, divided by something called the delta. So we will divide this one by delta. What is delta? Delta is the characteristic polynomial of this determinant of this matrix. So delta, in fact, it's the determinant of this matrix, which is R1 plus LS minus LS. This one minus LS. This one it's R2 plus 1 divided by CS plus LS. If you want to get this value, it will be that value multiplied by that value minus this value multiplied by this value. So I will write it, and we don't need to solve it in details. So it will be R1 plus LS multiplied by that part, which R2 plus 1 divided by CS plus LS negative, this one negative, negative plus, so it will be negative L square S square. So it will be like that part. And of course, we need to get the determinant of that part. This one, it will be this one multiplied by this one, it will be 0 minus Vs multiplied by negative Ls. So in fact, it will be Ls divided by this delta multiplied by V of S. And as you can see, we need to get the transfer function, and the transfer function, it's I2 divided by V of S. So just for this equation, just to divide by both sides by V of S. When we divide both sides by V of S, we will get in that side I2 divided by V, right? It will be I2 divided by V of S. So it will be LS divided by delta, right? We need to just make it simple. So we can go to the slides. So I can go back to the example. So in this example, I have this electrical network. And in this electrical network, we need to find the transfer function of I2 divided by V of S. We need to get this one divided by V of S. So first, we need to draw currents and voltage in this network. We need to draw this current. We need to give it a label, a name. We need to call it, for example, I1 of S. This one, it will be I2 of S. And we will use Kirchhoff voltage law to write the equation of the voltage in each loop. In the first loop, V of S equal R1 multiplied by I plus LS multiplied by I1 minus I2 equal V of S. We will go to the next loop, the second loop. We need to write the equation of the voltage around this loop. So it will be R2 multiplied by I2 plus 1 divided by CS, which is the impedance of that part, multiplied by I2 plus LS multiplied by I2 minus I1. So now we have two equations. This is equation number 1. This is equation number 2. So using these two equations, we will arrange it to make it more beautiful. So we will put I1 of S in one side minus LS multiplied by I2 of S equal V of S on the other side. And we will arrange also, so this is equation 1 dash, for example. This is equation 2 dash. We will arrange also equation number 2. And after that, we will put it in matrix 4. So it will be R1 plus LS multiplied by I1 of S minus LS multiplied by I2 of S equal V of S. So in fact, this is equation number 1 dash. In the second row, we will have equation 2 dash. So it will be minus LS multiplied by I1 plus that term multiplied by I2 equals. Now you want to write the transfer function G of S equal I2 divided by V of S. So now we need to get I2 in one side and the V of S on the other side. How can we do this? We will use something called the Cramer's rule. So Cramer's rule to solve it to get IT of S, I2 of S. So it will be determinant of this matrix, but we need to replace this column with the right-hand side. So we will just replace this column with V of S and 0. We replaced it. And we will divide it by delta. This part, in fact, is this determinant. It will be that part multiplied by 0. This part multiplied by 0, it will be 0. Minus V of S multiplied by minus L of S. So it will be LS multiplied by V of S divided by delta. What is delta? It will be the determinant of this matrix. So it will be that part multiplied by that part, negative that part minus that part multiplied by that part. And we will get it. And we will simplify. And once you did this, you will get your transfer function. So your transfer function will look like this one. So again, once you have the transfer function, it maps inputs into outputs. It tries to find the transition from input, they call it transfer function. So in fact, it transfers the input into the output. So we can draw a block diagram like this one. Inside it, we will have our transfer function G of S. The input will be V of S. The output will be I2 of S. So we can say that, okay, transfer function equal output divided by input, which is I2 of S divided by V of S. Please let me know if it's not clear. Is it clear or not? This one, is it clear? Can you hear me?
Yes, it's okay. Thank you.
Okay. So we can go to the next example. So in the next example, should I let you write the equation in front of you? I will give you 2 minutes or 3 minutes. So we have 3 loops in this example. As you can see, we have 3 loops in this example, right? So just this is loop number 1. We will have current 1 here, and we will have current number 2 in this loop, and we will have another current number 3 in the third loop. And I just asked you here to write the 3 equations. So we will have equation 1, equation 2, and equation 3, right? So I will give you one, maybe 2-3 minutes to try to write the equation. So I will put it in new slide here, and I will just take this image, copy. I will put it here in this figure, in this slide, and I will just ask you to write the 3 equations. Yes. Yes. Can you please start writing the first equation? We can select in order. Astrid, please. Can you tell me what will be the first equation, Astrid? Astrid. Okay, we can go to Daniel. Next one. Daniel. So anyone, please, anyone who is ready. Just the first equation, we will do it together. So Astrid, one more time. The first equation, can you tell me how the first equation will look like? Okay, Daniel, Askel, Hukun, anyone, please? Vitali? Nora?
We should just write the sum of
Yes.
for example, I1S multiply, I don't remember with what.
No, we need to write the voltage across the voltage around the first loop. So now we have first loop, second loop, and the third loop. So for the first loop, we need to write the voltage. So we know here we have here the source. Okay, back again. You see, this is my source, right? So the source here equal voltage across R. We have here another R. This is 1 ohm. This is 1 ohm. This is 2S. So what would be the first equation? So this is my
This
This is
resistor. Yeah.
this is your loop. Forget
Mhm.
about all other loops, right?
Mhm.
So now we need to write the equation of the voltage around this loop. Mhm. So we can start with the input.
Vs.
Yes. So can you tell me V of S
V of S
equal?
equal it is 1 or what or it is L on top.
No, this is one because this is resistance, 1 ohm. Yes.
So it means this resistor multiply with Is
By
I1.
I1 of S. Okay.
Yeah.
So it will be I1 of S. Yes. The second
Plus
plus
next resistor.
next resistor.
Yeah. Multiply multiply the same I1
I1 of S. Okay.
plus 2s. What is 2s? It is
2s. This one it's inductance. So L here, so it's LS in fact, but here L equal to.
Okay.
It will be 2s. Yeah.
Oh, that's why. Okay, now I understand. 2s multiply I1.
I1 of S. Okay.
I1
Is
of
it
S.
is it all?
Oh no, we should
Mhm.
minus
Yes. Very good.
I2
Minus I2 of S.
I2 of S multiply 2s
Multiplied by 2s.
or as well with 1.
Oh, very good. So minus I2 of S again because it's multiplied by 1.
Yes, exactly.
Okay. Are we missing anything here?
Let me check.
Yes.
This one.
Yes. You forgot something here.
I3 maybe?
Yes. Very good. I3.
Yeah.
So we need to subtract also I3 multiplied by 1. So we need to have here minus I3 of S because it's multiplied by 1. So if we need to write it one more time, so it will be like this one, V of S equal, we can start from this resistance, which is 1. The current in this resistance, in fact, it's I1 in one direction minus I3, correct? So we can just say that, okay, this one, it will be I1 minus I3 multiplied by 1, right? Very good. The second resistance, it will be plus. So the voltage drop across this one, it will be I1 minus also I2, right? So it will be I1 minus I2 multiplied by 1 plus 2S multiplied by I1 minus I2. So now this is equation. This is a good equation. So in fact, your equation was right, but I just ordered it here. I put it in order, right? And don't forget I3. Okay. Thank you very much.
You're welcome.
You are okay, Astrid. Thank you very much, Astrid.
It was Vitaly.
Vitaly. Okay, thank you very much, Vitaly. Yes.
So I have a question.
Hmm.
So the VS under the first V's you just wrote, is it just you just put them in parentheses?
Yeah, because
So what did you do there exactly? I didn't quite catch that.
no, I just asked you to write the three equation. So because here, for example, maybe the question here will be try to find G of S transfer function of I3 of S divided by V of S. It could be something like this one, right? So if someone asked you to write that is a transfer function of I3 divided by V of S, so in this case we need to write the three equations because we have three loops, and we will solve those three equations to find I3 divided by V of S, right? Correct? So it's just the question could be find the transfer function of I3 divided by V of S. It could be also I1 divided by V of S, or it could be I2 divided by V of S. So many questions, in fact, many questions. To do this, you need to write the three equations because we have three loops. So now we have the first equation. Everyone understands the first equation?
Yes.
Okay, can we write the second equation of loop number 2? Who will do it? Maybe Oscar, Nora, Mehrad, anyone please. Second equation.
You mean the same thing, but with second is circle.
Okay, so can you tell me how the second will look like?
Oh, second, it is what was on the right side, yes?
Yes, the second of the rest, because this is I2.
Okay.
Mm.
So I2 multiple 2s.
Can we start with, okay,
Okay.
I2?
Yeah.
Yes.
Mhm.
So the voltage here will be 0, or it will be what? Because we don't have any, I mean, loop number 2 does not have any source. There is no source.
There is 0.
0,
So
yes.
0, yeah, 0 equal.
So we don't have to write if it is 0, yes? We don't have
No,
to write.
no, you need to write it because this is the input to this loop will be 0, right? We need to
Okay.
write it because it's equation, something equals something, right? So we need to say that, okay, this one equal V of S or equal 0. So now in this case, it's equal 0. Okay, now we will write the voltage across this loop. Starting from, you can select from here, for example.
Okay. For S multiple I2.
My I2. Mhm.
I2. 3
Only I2?
minus I3
Very good. So I2 minus I3. This is very good. Plus
plus
the second part,
3s multiple
3S multiplied by
I2.
I2. Only I2. We don't have here anything. It's only
Yes,
I2.
only
Very
I2.
good. Yeah. Plus
2s multiply I2 or minus I1
very good. I2 minus I1. Very good. Yes.
plus I2 minus I1.
Very good. I2 minus I1. So it's become multiplied by 1. So now this is equation number 2.
So actually we
Very
don't
good.
need these brackets.
Yes. So this is equation number 2. What about equation number 3? Can we get someone else to answer? Magnus? Magnus.
What?
Oscar, can you write equation number 3, please?
I don't know. I don't think so.
Yeah, this is equation number 3. This
Yeah.
is loop number. We need to write the voltage around this loop.
Ooh. Yeah.
Yeah, we'll write it
Probably
with
1 divided by S times I3.
one more time.
1
divided-
divided by S times I3.
Yes, very good. 1 divided by S multiplied by I3.
Yes.
Yes. Plus, well, this is the voltage here.
Plus I3, no, for S times I3
For S.
minus 2 minus I2.
Very good. Excellent. Yeah.
And then it goes to 1 times I3 minus 1 I1.
Very excellent. Excellent. Equal.
And then equal 0, I think.
Very good, very good. So
Yeah.
this is excellent. So this is equation number 3. So now you have equation 1, equation 2, equation 3. From those those three equations, you will write it in matrix notation as we did in the last example. And if you want to get I1, you solve it for I1. If you want to get I1 divided by V of S, you solve it for I1. If you want to do it for I2, you solve it for I2. If you want to get for I3, you solve it for I3, and that is it. So this is very good. Okay, so this is the equations which you just mentioned to me in order. So we have those 3 equations, and you just mentioned it exactly, in fact, right? So just simplifying it, because I just simplified it, cleaning it. So what will be the value which is multiplied by I1 of S? It will be 2 plus 2S, 1 plus 2S, So just to try to arrange and fix. And you can write it in matrix form. So in matrix form, it will be a matrix of 3 elements multiplied by a vector of 3 elements. So it will be like this one, matrix multiplied by a vector. This vector will consist of I1, I2, I3 equal. On the other side, we will have V0, 0. And we will have here the coefficient, right? So it will be like this one. If you want to solve it for I1, you replace this column with this one, I2. If for I1, you replace the first column with the output, right hand side, and so on, and you will use the same rule which we did, which we used in the last example. Okay. Can you see? I'm writing in the board. Can you see my writing?
We see the PowerPoint slides.
Only the slides. You don't see that I'm writing.
Oh,
in
we see the
slides?
writing too. I meant the
Oh.
writing as well.
Okay, very good. Thank you. So now we will go to the second system. It's something called the translational mechanical system. So we use the electrical. There is also another system which is called translational. It's like this one. So it's a spring, for example, damper and the mass. So what will be what will be the transfer function describing it? If it is a spring, it will be easy. It will be K multiplied by integration of V, right? It will be just a K, in fact. It will be just a K, because K multiplied by distance. We will focus on the displacement. So it will be K multiplied by X, right? It will be K multiplied by X. In S domain, it will be like this one. Force in S domain, it will be K multiplied by X of S, right? If it is damper, so the transfer function, it will be F of S equal V or F multiplied by dx by dt. Dx by dt, it's the speed, in fact. So it will be S x of S. It will be like this one. The mass, it will generate a force which is proportional to the acceleration. So it will generate a force. I mean, if there is something, for example, you have your car and you try to push it, right? So in fact, if you need to push it, you need to generate a force. It will generate a force to resist you. This force will equal m multiplied by the acceleration. So in S domain, it will be F of S equal m s square x of S. It will be like this one. So this is the most important. We need to write the transfer function of the spring, damper, mass, and we can use those 3 elements for building large mechanical system or translational system, mechanical system. And sometimes you need to find the transfer function of it. So we will start with an example. We have this example. So in this example, it's we said that find the transfer function x of S divided by V of F of S for the system. You have this system. F of S, it's the force. And the X of S, it's the displacement, right? So you have a wall and you have a mass, and this mass connected to the wall with a spring and a damper. And you just try to find the relationship between F and X. F, in fact, is the force, because you can just pull it and try to drag it. When you drag it in that direction, it will move with a distance called the X of t, right? So he asks you what is the transfer function of this one. This is a very important problem, in fact, because there are many systems which are modeled in this way. So we need to find this equation. Do you see this one? We need to find this transfer function. So the transfer function here, G of S equal X of S divided by F of S. We need to find this relationship. So this relationship, it will be a second order system, as it is mentioned here, M S square plus FV S plus K. We need to find this relationship. How can we do this? In fact, solving this problem is very easy. We just need to follow those simple rules. So we need to begin the solution by drawing the free body diagram, where you place on the mass all forces felt by the mass. We need to draw something called the free body diagram. We assume that the mass is traveling to the right direction. We assume that this mass will move to, because you try to apply force from that direction. So in fact, you try to drag it to the right side. You try to drag it. When you drag it to the right side, it will move to the right hand side. So it is here now, for example, we will try to drag it to that location, for example. So what will happen? Because we apply force. This force, it's not pulling it. We don't push it. We try to pull it to the right hand side. So it will move to the right hand side. When it will move to the right hand side, there will be some some forces which will be generated to resist your force. One force will be generated by the spring. It will be K. It will be K multiplied by X. Number, it will generate a force. This force, in fact, it's proportional to the speed. So it will be FV multiplied by SX of S. And the mass itself, it will generate force, which will try to resist your force. It will be MS square X of S, because it will generate a force which is proportional to the acceleration. So the spring, it will generate a force which will proportional to the displacement distance. The dumper, it will generate a force which is proportional to the speed. And the mass, it will generate a force which is proportional to the acceleration. So now we need to solve it. So I will do it with you. So we will go to the next slide. In the next slide, we need to draw this something called the free body diagram. This is the free body diagram. Free body diagram means we will plot this mass, which is called this block, and it has a weight equal X, and there are some forces which are acting on it. There's this one to the right hand side. This is my input, right? So you have something connected to the wall. Maybe in the gym, you have something similar to this one in the gym, for example, and you try to drag it, to pull it. When you pull it, it will generate forces which will make you tired, right? Otherwise, you will not go to the gym because you need to practice. So you try to drag it to the left, to the right hand side. When you do this, there are some components which will generate force, which will resist you. The first part is the spring. The spring, it will generate a force proportional to the displacement. When X is small, this force will be 0. When X is 0, I mean this force, it will be 0. But when you try to drag it, maybe at the beginning it will be easy, and when you drag it more, when the distance increases, it will be much more difficult because X will increase, right? So we will get this force. This force, it will work on the opposite direction, right? You try to pull in the right hand side, and this force, in fact, it will oppose you, right? It will resist you. So it will generate a force which will work on the other side. Otherwise, it will help you. I mean, it will not be training if in the gym, for example. We have also dumper. The dumper, it will generate a force which will proportional to the speed. So it will generate a force equal Fv, which is proportional to the speed. The speed will be dx by dt. If the distance is x, speed will be dx by dt. So it will generate a force. This force will be Fv multiplied by dx by dt. Dx by dt, it's the speed, in fact, it's a v. Dx by dt, it's the speed. We call it speed. Also, this weight, this mass, it has a weight. This weight, it will generate a force, and this force is proportional to acceleration. So it will be m multiplied by a. A is the acceleration, which is d square x divided by dt square, right? So it will be like this one. So now we need to write the equation, because we need to get the transfer function of x of s divided by f of s. We need to get this one. The output divided by the input. F of s is the input, because if you are in the gym, you are pulling some device to the right hand side. So in fact, you are applying force. So in fact, you are providing input to your system. And what will happen? You try to drag something, and this object, it will move with you. When you apply force, it will move. It will move with a distance. So the output here will be the distance, right? So it will be x of s. So we need to write the transfer function of x of s divided by f of s. So what we will do, we'll just imagine that m will move to the right hand side. When it will move to the right side, what will happen? There will be some forces will be generated the spring will generate a force equal k multiplied by x of s in S domain. Dumper, it will generate a force which is proportional to the speed. So it will be Fv multiplied by Sx of s. Sx of s, it means dx by dt, which is the speed. And the mass itself, it will generate a force itself. This force is proportional to the acceleration. So the value of this force will be m s square x of s. S square x of s means it's d square x by dt square, which is acceleration. So if the distance or displacement equal x of s, so velocity will be sx of s. Acceleration, it will be s squared x of s. So now we will look into this diagram and we will write an equation. Forces on the right-hand side will equal to the forces on the left-hand side, right? So we can start with this left-hand side. So the forces acting on the left-hand side at equilibrium, because at equilibrium, the summation of forces here equals the summation of forces in the right-hand side. So we will sum it. So in this side, we will start with the large power. So it will be ms square x of s plus fvs x of s plus kx of s equal, on the other side, we have f of s, right? So the forces acting on the left-hand side, or when you apply force on the right-hand side, this object, it will generate forces which will reject you, it will resist you. And at some point, both forces will be equal. Because when you go for training in the gym, you try to pull this one time, 2 times, 3 times. In fact, you pull it to the right-hand side, and at some point, your force, you cannot do it anymore. So your force equal to the forces which are generated from the object. So at equilibrium, forces acting on the object from the left equal to the forces acting from the right. So the summation of those 3 forces equal f of s. When you look into this equation, you can see that we have x of s common factor, x of s common factor, x of s common factor. We take it as a common factor. So what will remain will be ms square plus fvs plus k multiplied by x of s equal f of s. We need to get the transfer function, which is x of s divided f of s. So just to divide both sides by that part. When we divide the left side by that part, we will have x of s. So just to divide, so it will be x of s equal 1 divided by ms square plus fvs plus k multiplied by f of s. Divide again both sides by f of s. When we divide both sides by f of s will cancel f of s, so we will have the transfer function, which is g of s equal x of s divided by f of s. It will be 1 divided by ms square plus fv of s plus k. This one also is second order system. Second order. So in fact, when we draw the response, if this one is time, we should expect that when you have a force equal f, maybe you will get distance, it will follow this second order behavior. Is it okay? Do you like to solve this one more time? So keep those changes. Yes. So I will draw it one more time, so we can solve it one more time. But maybe we can copy this. Okay. I need to copy. Okay. Now this is very large figure, so sorry for this, but we will try to make it smaller. Okay. So we can solve this example because it's very important. Yes, we will start with this one. Okay. Okay. You have this one. Imagine that you are in exam and someone asked you to write the transfer function of that part, how we will solve it. So as I told you here, we need to get the transfer function, which is g of s equal x of s divided f of s. How we will solve it. how we will solve it. This one is the input. This is the force which you are applying in the gym. This is your input. This one, displacement, it is the output. Imagine your car is broken and you ask someone to push it. So he will apply force and it will move. So the input will be force and the output will be distance or displacement, right? And in the gym, you're applying the same also. You have maybe some devices in the gym, you are training with it, you apply force, and this object or the system will move, or part of it will move. So now let us solve this problem one more time. So we will draw this free body diagram and we will put it in S domain. Okay, it will be like this one. Imagine that we are moving this object M to the right hand side. So I will apply force F of S and I will try to move it in that side. So it will move with a distance X of S. When we try to do this, there will be some forces which will resist me. So one force will be generated on the opposite side. This force will be generated by the spring. How much force? It will be K multiplied by displacement X of S. Okay, so this one will come from the springer. We'll call the spring? Yeah, spring. Okay, so the damper, it will generate a force. This one is the second one, it's damper. It will generate a force. This force, in fact, it has coefficient called FV multiplied by, it will proportional to the velocity. So the velocity will be Sx of S. And this object has weight, momentum, or it will generate also a force. This force will proportional to the acceleration. So it will be M multiplied by A. A is acceleration, or mg. So imagine it's weight, M multiplied by G, gravity, for example. So it will be multiplied by something proportional to the acceleration. So the acceleration of xs, it will be S squared X of S. Now we will write the equation of forces. Summation of forces, sum here equal F of S. Summation of forces in that side equal F of S. So it will be ms squared plus fvs plus k multiplied by X of S equal F of S. We need to get the transfer function, which is X of S divided by F of S. So this one divided by this one. This one divided by this one, it will be the coefficient of this one divided by that part. So it will be 1 divided by m squared plus FVS plus k. So now we are solving it. So now we have the transfer function of our simple system. Now we need to solve more complex one. We will take a more complex example like this one. It's not complex, don't worry, it's easy. It's just two objects connected together, right? So we have two objects and each object has a weight. This one has a weight M1 and this one has a weight M2 and they are connected with each other. They are both on the floor. And this one is connected with spring, which has a coefficient K1. Both are connected with K2 and FV3. This one is connected with the wall with K3, for example. So it looks like complex. It's 2 degrees of freedom, translational mechanical system. We have here FV1 and FV2. It's a damper also. We have here damper connected with M1. So we have something like this one, correct? Okay, so now we need to solve this complex problem. So the solution, in fact, we need to use something called superposition to draw the free body diagram. We will draw free body diagram, but we will do a trick. We will use something called superposition. So we will hold M1, we will hold M2, and we will move M1 to the right, and we will find the forces which are acting on M1. And we will repeat it again. We will hold M1, and we will move M2 to the right side, and we will write the equation of the forces acting on M2. Now we will have set of equations acting on M1 and M2. We will solve them together, and we will solve our problem. So we will start with M1. So this is my original system. right? So this is your system. So just fix this one, hold M2, right? Hold M2 means we will keep M2 standstill. And we will try to move M1 to the right side. We will push it to the right side. What will happen? There are some forces which will be generated from M1. First of all, when we try to move M1 to that side, what will happen? This one will reject it. This one will generate force, right? This spring, it will generate force called K1 X1 of S. Because in fact, when we hold M2, X2 of S will be 0. But now we are moving M1 to the right side. So X1 of T, it will change, right? X1 of T, it will change. It will have a value, right? So now we need to write the forces which are acting on M1. So first, this one will resist, right? First, we apply here Ft on M1. In fact, we apply Ft on M1. So we will have F of S acting. Try to push it to the right side. But at the same time, K1, it will generate a force which will resist this movement. It will generate a force on the opposite direction called K1 times X1 of S. So this is number one. And we have this number. It will resist. It will generate a force which will reject this movement. So it will generate a force called FV1 multiplied by the speed of M1. So it will be FV1 multiplied by S, X1 of S. And also the weight, M1, it will generate also a force, which will, because it's heavy, so it will generate a force which will resist this movement to the right side. So it will generate a force called M1 multiplied by acceleration. Acceleration will be S squared multiplied by X1 of S. So we will have also, so this force will act in that direction. This force will act in this direction. This force will act in this direction. Only F of S, it will act on the opposite side, because as you can see, it has this direction here. So this force will try to push you to the right-hand side. Okay, this is one side. What about the other side? In fact, if you try to move M1 to that side, in fact, also K2 will resist you. And this number, it will resist you because it will generate force acting on the left side. So K2, it will generate a force acting on that side. What will be the value of this force? It will be K2 multiplied by X1. Also, FV3, it will generate a force acting on that direction. And this force, in fact, it will be proportional to the speed. So it will generate a force equal FV3 multiplied by S X1 of S. So this is the first step, right? Just move M1 to the right-hand side. Sorry, hold M2 and move M1 to the hand right side and draw the free body diagram and write all forces, right? Okay, so now we will write the equation of the forces acting on M1. What will be the equation? Okay, summation of the forces on the left-hand side equal to the summation of the forces on the left-hand side. Just write it, right? So we will assume that all forces which are acting on the right, it will be positive. So F of S, it will be, so all other forces are acting on the opposite direction to F of S. So the summation of all those forces acting to the left will equal to F of S. What are the value of those forces? It will be, we can start with K1. So it will be we start with S squared, sorry. It will be M1 S squared multiplied by X1. This one plus this one plus this one plus this one plus this one equal F of S. Right? So it will be M1 S squared X1 of S plus FV1 plus FV3 S X1 of S. So it will be like this one, FV1 plus FV3 S multiplied X1 of S. Plus, we have here K1 plus K2. K1 X of S plus K2 X, K1 plus K2 X of S. Yeah, this one. So in fact, this is the forces. These forces equal F of S. But there is something missing, right? We use something called the superposition, and to use this superposition, we need also to hold M1 and move M2 to the right side. If we will hold M1 and just move M2 to the right side, what will happen? In fact, X2 will change, X1 will stand still, it will be 0 because we are holding M1, but we are just moving M2 to the right side. When you move M2 to the right side, what will happen? In fact, this one will generate a force, K2, and if V3, it will generate a force, which will try to resist the movement of M2. But because K2 and the VV3 are not connected to a wall, they are connected to M1. So they will try to move M1 to that direction, right? So you have a rope, for example, and you connect this rope to your car, and you try to drag this rope. When you are dragging the rope will drag the car, right? So we are here applying forces on M2, and as a result of this, the spring, it will generate a force, and the damper, it will generate a force which will try to drag M1 to the right hand side. So now we will draw the free body diagram of M1 again, and we will see those forces. So we will have K2 multiplied by X2 of S, K2 multiplied by X2 of S. It will move into the right side. Also, we have this damper. It will generate a force called FV3 multiplied by X2 of S. And those two will generate a force which will try to drag M1 to the right side. We will sum together. So we will put all forces together in one figure, combine all forces, and write the equation. Right? Is the equation. So this one plus this one plus this one equal F of S plus this one plus this one. Right? So just to move this one and this one to the other side with negative sign. So now we are happy. Now we have an equation, and this equation describes the forces acting on M1. I know that you want to go because now it's 4. We have 2 minutes. So should we continue this example, or we can do it next time? Should we complete this example first?
Many of the robotics students have a class in 15 minutes at TF. So.
You have another class in 15 minutes.
Yes, in 15.
Okay, so now we will finish here. We will stop it. Is it possible to take another time extra because we lost 1 hour today, or should we start next week on time, and we can have 2 hours next time between, so we can have 6 hours next Wednesday? Is it okay? So I will stop here today, but is it okay to use 2 extra hours next week? So we can compensate the technical problems which happened today.
Just one moment. And next week from 12 to 2 career day. So we
you are not free. You can't.
Yes, we can't from 12 to 2.
Oh, okay, so this is fine. So we can start next week from 10. Right? And we will take 4 hours. I mean, we can start next week on time from 10, and we will close at 12. And after that, we can take another session from 2 to 4.
Yes.
But please try to go through those slides and try to solve those examples, so we can, we can cover it next week, the rest of it next week. Thank you very much.
You could also record if it's possible, so we could also see it in our spare time.
Yeah, okay. It could be also good choice, a good idea also. Yes. Okay, so thank you very much, and see you next week.
Yeah, see ya.
Thank you.
See you. Bye-bye. Bye-bye.